All right, class, today we are going to be looking at how to use protractors and measuring angles and how we can take what we already know about angles in order to help us measure with a protractor correctly. So if you guys remember with measuring angles, even if we don't have a protractor, we can look and identify that there are three types of angles. The first type of angle that we have is an acute angle. And remember, an acute angle is going to be an angle like this that is less than 90 degrees. Then we have the right angle, and you can see that's a perfect perpendicular angle that is exactly 90 degrees. And then we have our very large obtuse angle that is more than 90 degrees. And the reason we're reviewing these and the reason we've been looking at them, estimating with them, is because when you start to use your protractor in order to measure an angle, and remember that 180 degrees is a straight line, if you notice that there is an angle that is lined up on the vertex, you always line up your angle on the vertex, which is where two rays meet. So let's say that you have one ray that goes out this way, and the other ray goes out this way, and you're trying to figure out what is the measurement of this angle here. I can already look at that angle and tell that that angle has to be obtuse. So if for some reason I'm using my protractor and there are two sets of numbers on a protractor, both sides start off at 0, and one will go this way to 180, and the other one will go this way to 180. And you might have to wonder, well, which set of numbers should I use? You need to use the one that lines up with the bottom line and starts at 0. And I can see that my ray goes this way, so I'm going to start at 0 here, and then my angle ends up somewhere over here. So that probably is, it's not 180 degrees, which is a straight line, but maybe that's at about 120 degrees, right about there. And that makes sense because 120 degrees is an obtuse angle. But if I made a mistake and I started off 0 this way and started measuring, and I said it's only 40 degrees, or maybe I said it's only 60 degrees, something like that, does it make sense to say that this large angle here is only 60 degrees? Well, no, because then that would be an acute angle, and it's definitely not acute. It is huge. It's obtuse. So that would tell me that I made a mistake using my protractor. I must be measuring on the wrong side. Oh yeah, I have to start with 0 and work my way up. This is an obtuse angle. It can't be 60. So we take what we know about angle measurements and what they look like to help us measure more correctly with the protractor. We're going to be able to tell if we're measuring with the wrong side on accident if it does not look correct. All right, so let's keep thinking about angles. There are all types of angles out there, and there are different careers and jobs that use angles. So what are some places in the real world that you think that we may need to know how to measure an angle? And obviously we can think about school. You know, we're learning how to measure angles in school, but there are people with jobs that maybe they're builders. Maybe we have architects that are building buildings and they want to make sure that all their angles are correct in order to keep this house strong and sturdy. There's also engineers. Engineers are people that build things, and maybe they need to know the angle of every single corner to make a product correctly. So angles are super important. We just want to understand how big and how small they are. And then a protractor will help us get even more precise. So how do we use protractors? Protractors are a tool that is used to measure angles. A protractor has two number lines so that you can measure an angle facing any direction. That's why there's two rows of numbers. So if you look up here, this one angle right here, it looks really large to me. This looks like an obtuse angle. And when I'm looking at the numbers, remember I told you want to start off at the 0. So this inner row of numbers starts off at 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, and it looks like that angle is about 100 degrees. And that makes sense because it's open a little more than 90 degrees, I can tell. Don't choose to start counting with 180. If the angle opens this direction, start off with the number with the 0. If you go 180 and down, it's like saying that this is an 80-degree angle, which I know that this angle is larger than 80 degrees. And I know that I have chosen the wrong measurement. So I'm not going to use the outer ones. I'm only going to use the inner ones and start at 0. So you have to make sure you're using the correct row of numbers, and I do that by looking at the bottom line that's lined up with 0, and I use that row of numbers to count up. All right, now this is going to really help us to understand a circle and how protractors work. So a circle is a full 360 degrees. Remember when we used to play in class and I would say do a full turn? A circle is 360 degrees, the circle of life. We always talk about that. A protractor is like cutting that circle in half. And if you think about 360 divided in half or divided by 2, it's actually 180 degrees. And that's how we come up with 180 degrees as a straight line. So the protractor is going to measure anywhere between 0 and 180 degrees on either side. 0 up to 180 degrees. Okay? So it's just depending on where our vertex of the angle is, where we're going to end up drawing that vertex, putting the other angles up. Like this one is a perfect 90-degree angle, right? So we could start off at 0 and go up to 90. So just remember your protractor is going to start at 0 and go to 180. Now let's take what we know about angles to see if we're measuring correctly using a protractor. So this is the angle we're looking at right here. A couple things I notice about it already. I definitely think this is an acute angle, which means I think it's less than 90 degrees. So I need to check and see, am I using the correct form of measurement? Which is more reasonable, to say that this angle is 40 degrees because I can see the 40 right there, or to say that this angle is 140 degrees? Well, 140 degrees is way larger than 90, and I can tell this is not an obtuse angle. So I'm going to get rid of that. I'm going to say it's more reasonable to say that this angle is 40 degrees, and that makes sense because the 0 starts here. You have that bottom line, line it up with the 0, and I'm going to count up 10, 20, 30, 40. I'm actually not going to use this outer row because there's no way that this is a 140-degree angle. It has to be 40. So let's look at another one. Which is more reasonable to say? Is it more reasonable to say that this very large angle is 40 degrees or 140 degrees? And if you're like, well, where are you getting these numbers from? Well, when the angle opens up, well, it lands over here and I look at the two measurements, 40 or 140. And to me, it's definitely looking obtuse. So it's more reasonable to say it's got to be the 140-degree angle. And I know that for sure because I always look at this bottom line, make sure it starts off with the 0, and I choose that row of numbers to count off. I don't want to go 180 and backwards. I want to start off with the 0 and go all the way up to 140. And to me, that makes sense that this is a 140-degree angle. Look at this one. Which is more reasonable to say? Is it more reasonable to say that this is, oh, hold on, my little pen thing is in the way. Is it more reasonable to say that it asked if it was 90 degrees or 45 degrees? Well, in this one, I can see that this is the 0 baseline, and it's landing right there at 90 degrees. So it's more reasonable to say that this is 90 degrees. So I also